the day 5 of series Learn Python from Basics to Advanced, and you are watching Dever 5. I am adding all the uploaded videos of this series to this playlist. You can find the link in description below. Previously I have explained about strings in Python, and today we are going to learn about operators in Python. So what are operators? Operators are special symbols that perform operations on variables or values. For example, addition, subtraction, etc. These operators are categorized into 7 categories: arithmetic, assignment, comparison, logical, bitwise, membership, and identity. So let us take a look at each and every one of them. So first we have got arithmetic operators. So what are arithmetic operators? Arithmetic operators allow us to perform basic mathematical operations. Here are the most common operations we can perform using arithmetic operators. 5 plus 6 is equals to, and we can do 5 plus 6, and that gives us the output of 5 plus 6. Similarly, if we can do 5 minus 6, and 5 minus 6 will give us -1. So these are all the operators which are present in arithmetic operators. First we have got addition, subtraction, multiplication, division. Then we have got floor division, exponent, and modulus. We know what these are. We will understand what floor division is and modulus is. The exponent operator is also easy. If you do 10 to the power, so this will be 10 to the power 2, and it should give us 100. Similarly, if we do 2 to the power 10, then it should give us 1024. We are doing. If we do 2 to the power 4, it gives 8. That is equivalent to 2 into 2 into 2 into 2. Okay, my bad. 2 to the power 4 we are supposed to do. So that gives us 16, and it is equivalent to this. What is floor division? First, let us take a look at division. If we do 11 divided by 3, we get 3.66 something. If we do 11 floor division of 3, then we will get 3. What it does is round off to the lowest integer, okay? Here we are getting 3.666, and here we are only getting 3. So we don't get decimal values in floor division. Similarly, we have got modulus over here. What is modulus? What does it do? So if we do 10 modulo of 2, then we get 0, because 10 is divisible by 2. Similarly, if I do 11 modulus of 2, then it will give me a remainder of 1, and if we do, then it will give us 3. So 8 ones are 8 is taken, and then 3 is left. So this is the remainder. So the modulus gives us the remainder. Next we have got assignment operators. So the assignment operators are, first we have got equals to, then plus equals, minus equal, multiply, and equals. The actual main part of the assignment operators is this one, okay? What we are assigning, a is equals to 10. So this is the assignment. A plus equals 1 if we do, then it is equivalent of a is equals to a plus 1. So if I print a again, it will be 11. Similarly, we have got minus, plus, etc. Okay, minus, division, floor, modulus, almost all the arithmetic operators you can use here, and let us use modulus here, and we get a is equals to 0. So these are the assignment operators, and these are the shorthands. Now moving on, we have got comparison operators. The name itself is self-explanatory. We are comparing two values or two variables. Here we have got is equals to, not equals to, and then less than, greater than, less than equal, and greater than equal. So let us see the examples of these. Let us assign a is equals to 10 and b is equals to 5. If we do a is equals to 10, then it will give us true. And similarly, if I do a is equals to b, then it will return false, because 10 is not equals to 5. But if I do a is not equals to b, then it will return true, because 10 is not equals to 5. And similarly, these are the other comparison operators. A less than b, a greater than b, true, because 10 is greater than 5. And over here, a is less than b, it returns false, because 10 is not less than 5. 10 is greater than 5. That's why it returned true in next statement. Now we have less than equals to and greater than equals to. For this, we will do print 1 is equals to 1, and we will do 1 less than equals to 1. Here it is returning true. Now if I do less than 1, then it will return false, because 1 can be either less than 1 or can be equals to 1. For either condition it will return true. If I do 0 is less than or equals to 1, then also it will return true, because 0 is less than 1, and here 1 is equals to 1. I hope this clears the understanding of less than equals to operator, and same is for greater than equals to operator. Next we have got logical operators. What are logical operators? Logical operators are used to combine conditional statements. There are 3 logical operators in Python, and those are AND, OR, and NOT. Okay, so these are the 3 logical operators we have in Python. Let us see each of them one by one. True and true will return true. What it means is, let us see, 1 is less than 5. This condition is true. Alright, now let us combine this condition with 5 is less than 10. So this is also true. So both conditions are true, right? So resultant will also be true. But if I do something like 5 is greater than 10 and 1 is less than 5, so this condition is true and this condition is false. So it will return false. What AND operator does is it checks all the conditions. If all conditions are true, then only it will return true. If any one of the condition is false, then it will return false. Okay. Whereas in OR operator, it checks if any one of the condition is true, then it will return true. Here the 5 is greater than 10, it is false, but 1 is less than 5, it is true. So it will return true because the first condition is true. True or false, it will return true. False or true, false or false, it will return false. Whereas in AND operator, it will return false for us. And then comes NOT operators. Basically what it does is complements the resultant output. Okay, not of 1 less than 5. So 1 is less than 5, yes, so it will return true. But what NOT operator does is it will complement it. So 1 is not less than 5, it is after complement, so it complemented true. Not of true, false, and not of false is true. Let us see bitwise operators as well. Bitwise operators are used to perform bit level operations. These operators treat operands as sequence of binary digits. So let us see examples of bitwise operators. We will assign a is equals to 1 and b is equals to 2. Here if I do a and b, then I will get 0. Let us see example why it's happening. So bitwise operator, we have got 1 is represented as 0 1, and similarly 0 is represented as 0 0 in binaries. Okay, and 2 1 0 3 1 1. Okay, now if we see, it is doing AND operation between a and b. So here we are performing operation between 1 and 2. So what it is doing is 0 1 we get 0, then 1 0 we get 0. So what is the result? 0 0. What is 0 0? It is 0. Okay, so these are the binaries and these are the decimals. Don't get confused. What it is doing is performing AND operation between the binaries of these numbers and then giving the resultant output as decimal. Next, in bitwise operator, we have got or, not, XOR, left shift, right shift. We have all those. You can search them up, but we will not go deep into this. This is just basic programming. So let us see A or B, and it should be returning 3. Okay, A or B. So here we see 0 or 1, it is 1. 1 or 0, it is 1. And that's it. Then there is a NOT operator. NOT of A is -2. What it is doing is complementing them. Okay, what we have A, that is 1. And in binaries, negative is represented with 1 and positive is represented with 0. Okay, so here we have -1. What is happening with not A here is we have 1, not of 1 will result as -2. So 0 being complemented to 1 and then 0 being complemented to 1, and we will get -2 here, then 1 is being complemented to 0. So that's how NOT operator is performed as bitwise operator, and we are getting -2 with that. Now moving on, let's see membership operators, and then we will end the video with identity operators. So what are membership operators? Membership operators are used to test if a sequence is present in an object. The operations are, so what are membership operators? Membership operators are, first we have got in, second not in, basically complement of this. Okay, so let's say we have the list of numbers. We can say 1 comma 2 comma 3 comma 5 comma 6 comma 7. Okay, let us assign it to A. Now we can see we have a list. Okay, now if I do 1 in A, and it will return true because 1 is present in A. So 1 is the member of A. That's correct, right? Now if I do 10 in A, it will return false because 10 is not the member of this list. Similarly, if I do for not in operator 10 not in A, we get true because 10 is not a member of A. Similarly, we can do this for string as well. Let's say name. Okay, name is equals to dev path, and if I do D in name, and we will get true because, okay, my bad, D I have to put it in string, not variable. So let's see again, D string in name, we will get true because D is present. Similarly, if I try lowercase d, then it will return false because lowercase d is not present in dev path, our name. Okay, with that, membership operators should be clear. Now let us move on to identity operators. So what are identity operators? Identity operators check for the memory location of the variables. Okay, for example, here we will take A is equals to 1 comma 2 comma 3 comma 4, and we will give B is equals to A. So A is B and it will return true. Why? Because the A is reference to the B. So B is holding memory location of A. Okay, now we will introduce another variable C. and we will assign same 1 comma 2 comma 3 comma 4, and let's check if A is B. If A is C, and it will return false. Even though the lists are same, the memory location of both of these variables is different. Okay, if we do A is equals to B, then it will return true. A is equals to C, then it will also return true. So the elements are same. Okay, both lists are same, but the memory location we are checking using is operator. So AC will return false because the memory location of A and C is different. If I do A is not C, then we know the answer will be true because the memory location is not same as C. So with this, we will end up the video. Thank you for watching. Hope you have enjoyed and learned something from it. Thank you. Bye bye.